All right, a few more things about the science before we go on to applying the ecological approach or before we go on to discussing the ecological approach to training or specifically to BJJ. After the last video, I took a break, went out in the local forest for a bit, and then coming back, I noticed there were more tabs on the window I had open that I forgot to go over, but oh well, the last video was an hour long, so good, all good. Now, some things to cover. More of the ideas of Gibson. Here we got. Here's a little bit about affordances. The little entry on Wikipedia has actually some good stuff, and it's got a quote from something else. So, as it says, talking about Gibson's concept of affordance and how it is a broad abstract concept that integrates and puts into one. It identifies environment, animal, needs of the animal, and interaction of animal with environment. But it says here, a good point, the theory of affordances introduces a value-rich ecological object. Affordances cannot be described within the value-neutral language of physics, but rather introduces notions of benefits and injuries to someone. An affordance captures this beneficial, injurious aspect of objects and relates them to the animal for whom they are well or ill suited. During childhood development, a child learns to perceive not only the affordances for the self, but also how those same objects furnish similar affordances for another. A child can be introduced to the conventional meaning of an object by manipulating which objects command attention and demonstrating how to use the object through its central function. Unquote. That hopefully helps a little bit more too. You know, as we said, goals and needs come into play. In other words, values. So I like that way of putting it. It's a value-rich object, and looking at the references, looks like they're quoting J. Gibson himself from 1979 in his The Theory of Affordances, a chapter in the Ecological Approach to Visual Perception. So there's a little bit more about that. Now, here's something about invariance, a little bit more about that. And it's an invariant with a TS. I shall write it so we see, because sometimes pronouncing the word, you don't see how to spell it exactly. But here, first of all, in my great, beautiful handwriting, better than calligraphy. Okay, not, obviously. I just said not for those who couldn't figure it out on their own. I know most of you know I meant I was being ironic, but some people don't know that. So you have to tell them that you're being ironic. Affordances, and then invariance. Invariance is like that. ANTS, not NCE. Okay. It's not like that. So, as it says here, University of Alberta, Canada website, an invariant, the concept, is a critical component of Gibson's 1979 theory of ecological perception. In this theory, visual stimulation is viewed as a dynamic flux, which is produced by changes in the world or by changes in viewing position due to locomotion through the world. This dynamic flux is highly variable. However, in all of this variability, some characteristics will remain constant. These are the invariants of the optic array. And Gibson claims that these invariants are picked up by direct perception and specify affordances to the perceiving agent. Importantly, Gibson's invariants are second-order properties. That is, what is invariant in an optic array is a relationship between two of its varying components. The components vary, but the relationship does not. And here, Gibson himself says in an appendix to the ecological approach to visual perception, I think it is. I'll scroll that later. But here, the concept, in appendix 2, the concept of invariance in ecological optics. I'll read a little bit of this. So we see what he means. Then you can apply it to balancing on a board, a 2x4 on the floor, or a 2x4 in the air, balanced well, or something shaky. Or you can apply it to running through the forest. Where can you move? Where can you step? What things do you got to run around? When do you need to duck? When do you need to crawl? And so on. So, quote, the theory of the concurrent awareness of persistence and change requires the assumption of invariance that underlie change of the optic array. 4 kinds of invariance have been postulated. Those that underlie change of illumination, those that underlie change of the point of observation, those that underlie overlapping samples, and those that underlie a local disturbance of structure. It would simplify matters if all these kinds of change in the optic array could be understood as transformations in the sense of mappings, borrowing the term from projective geometry and topology, unquote, mathematics. Transformation in the sense being a mathematical concept, a mathematical transformation, not geological or chemical or something like that. Okay. Quote, the invariants under transformation have been worked out. Moreover, it is easy to visualize a form being transposed, inverted, reversed, enlarged, reduced, or foreshortened by slant, and we can imagine it being deformed in various ways. But, unhappily, some of these changes cannot be understood as one-to-one mappings, either projective or topological. Chapter 6. Consider the 4 kinds. So, I'm having to, unquote, I'm having to translate a little bit on the fly because it looks like someone used some software to translate this. And instead of OF for of, some of these changes, it's O open parenthesis. And it says, instead of either projective or topological, it says protective or topological. Projective does not make sense in this mathematical context. So it has to be projective. Because before, as he said borrowing the term from projective geometry, not protective. But here also, instead of likely, it's got LI and then the little hat, like I think above the number 6 it is, if I'm remembering correctly, on a keyboard when you type LI hat EY instead of likely. But so you get a little more of this, but see more of what that helps you see what an invariant is anyway. Something constant while you're moving in a situation. For example, as Rob Gray says, the relationship between you moving and a ball that you're trying to catch. And it makes more sense. I'll read this first, and we'll talk about like invariance and why it makes sense. But invariance of optical structure under changing illumination. This is like point one. Sunlight, moonlight, and lamplight can fluctuate in intensity, alter the direction from which they likely came to the layout, and differ in color. Hence, the illumination can change in amount, in direction, and in spectral composition. Some features of the optic array in the medium will change accordingly. There must be invariance for perceiving some kind of surfaces. Maybe it says tile. Their relative layout and their relative reflectances, they are not yet known, but they almost certainly involve ratios of intensity and color among parts of the array. Chapter 5, period, unquote. As he says, he's a scientist. We have more to learn. They are not yet known. That's what he's doing here. He's starting a new theory. So just like Galileo, we have more to learn. We got to have people develop Galileo's theory. We have to have Newton come along, and so on and so forth. There's so many other people besides Newton. And so, since some of this, the way the software read, some of this is really getting bad now. Like here's a word spelled Deeremefts, Deriemefts of structure. And then there's Suikrac, arrow 5, Miidergo. Okay, so I need a copy of this book that came out correct. Some of this is getting kind of crazy. But you get some idea about invariance, and he does talk about it a little bit in this appendix, and then I'm sure in the scientific literature out there, Google Scholar, there's more. We could ask Dr. Gray and other people. So there's more about invariance and the science and what they are. Important concept for the ecological approach. You got to understand invariance. You got to understand affordances like that. A person to need some kind of complex calculating and physics calculating dictator in our head. You know, evolution and quick decision making needs to be about simplicity. What is something simple we can use to direct and steer our motion to achieve goals? We want to try to be efficient. We should. I recommend it. Good stuff. It's fun anyway. Challenging. And balance is an underrated skill. Under-practiced, underappreciated in the United States. Way more of it needs to be done by people. And then you could add strength training to it also. There's a lot we could do. Dynamic balance, static balance, strength balance in the real world. I don't mean just balancing on some goofy ball. I mean doing stuff in the real world. Practical, effective, powerful, and fun. Now, let's say, as I said before, to repeat an example, if you're on, like I was today, a branch that's supported. This branch I was on was over a little creek, not much water in it right now at this time of year. Partly on the ground, partly on part of a fallen log. And it was unsteady. It took some practice to be able to walk across it without falling off. It was a nice challenge, really difficult. I do explore ways to do it, as Rob Gray talks about, as Gibson talks about. You know, it's something we do in our nature to figure things out. And it's something we should recognize and conceptualize and put into practice. Just because we do something sometimes without knowing it doesn't mean we understand it conceptually or have identified it conceptually. I know if I drop something that's going to fall, but that does not mean at all that we understand anything about gravity. We got the basis to form it, but conceptually we don't get it. Implicitly it's there if we figure it out right. A lot of people see something fall and they don't have a good explanation of it. So to explain it, to put it into scientific terms, to see why and how it conceptually is entirely different than being aware of its real existence. There's some kind of so-called higher animals with a consciousness getting up more towards ours. They know if you drop something, it falls, but they don't understand gravity. They haven't grasped it conceptually. But on a branch, like the one I was on, it's up in the air, being supported. As I said, we don't calculate the moment of inertia of the branch, its rotational characteristics, our balance, the branch's balance, how well supported it is, our center of mass, the pull of gravity on us, F equals capital G times M1 times M2, all divided by R squared and all that stuff. We don't do it for the branch. We don't have to. We don't know it. As I said earlier, squirrels go across a branch and they don't know that. It makes zero sense for us to evolve to have to calculate all that stuff to do something so simple as walk across a branch. Although in this case, of course, it's difficult. We don't got to know the torque, the area, surface area of our feet on the branch, the force of our feet on the branch, the pressure of our feet on the branch. Neither does a squirrel. We need something, if it's going to happen fast, quick, and efficient, we need something simple. We need some, we look neurologically and perceptually for invariance in the situation. And then, through evolution, we don't always get the so-called best product or output, but we get the most efficient in our context, given prior lines of development, what we come out of, what we're engineered to have. We get something efficient, given what's been engineered. That's something involved in the ecological approach, evolution, adaptation, all that. So there again, it's more context that helps you see how you get the idea of the ecological approach and what it means. This is stuff you need to know to really dig into it and understand it. To repeat, now that we've done that, think, given I know that, and given that's the way it is, can we characterize the ecological approach as just figuring it out yourself? No. Is it just learning by sparring? No. Is it something we've been doing for a long time? No. As you've seen from stuff we've talked about, stuff Gibson said, how scientists have and do, many of them being influenced explicitly or implicitly by Plato and Immanuel Kant and Dewey, they do stuff that's wrong. Now, I'm listening to a book by Dr. Robert Gray right now that's good. And it's Learning to Optimize Movement. Subtitled, Harnessing the Power of the Athlete-Environment Relationship. Good stuff. And one thing he brought up in there recently is how he points at how, does everyone have to have the same quote-unquote mental model in their head for some dictator to give them orders? Or is there some shared mental model? They got the same thing? Is that what they have to have? Like a diagram, partly a diagram on a board showing like a American football play? Or can they just do something simple like react to the same affordances and invariance? And then they can learn, as the Wikipedia thing said earlier, and as we know all humans do, as Gibson knew, as Rob Gray knew, we learn as we develop. Do people learn on one team the affordances someone else recognizes, and then what the other teammate affords to them? Someone else doesn't know this player, doesn't know how they work, what they do, whereas someone on the team does. And so they know the person and the values. Like B knows, here's A that we're talking about. B knows the values A can help him accomplish. Someone else on another team doesn't know them as well, but can learn some as they're playing a game. So being on the same team, you learn what someone else is a part of your environment is what they can afford you. And you learn what affordances they look for and things like that. What can people do in an environment? How do they respond? How do they adapt? And then what are some invariants? What are some simple things? You don't need some big, complicated mental model, And it's been shown with birds that fly in flocks. People have studied that. You probably know. All these birds are flying around together. How do they not fly into each other? Oh, they must need some mental model. They do these calculations and they're all flying together and they know where to turn in all these degrees and stuff. Nonsense. All they do is look at the one near them. That's all they have to do. It's simple. All these birds, you look at what's going on with your neighbors, they look at what's going on with their neighbors, and then this whole flock can turn and fly together. It's been proven. There's scientific research, You probably know about it. If not, of course, you can easily look it up. But, so this stuff applies to teams as well as individuals. And then, in terms of coaching, when you train a team, when you coach, when you're practicing on your own, you can be looking for things like that instead of memorizing a play. Like, does anybody really know, oh, the other team's playing a 4-2-4, blah, 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 like in what the world calls football. You don't got to know they're playing a 4-2-4 or all this other stuff for a particular situation. You look at what can be afforded by the situation in context of the sport and the rules. A particular situation, what are the simple things that allow you to get something accomplished, and that's all you need. So this applies, as I say, to teams as well. Okay, now one more note. I've talked about variables, variation, measurement, how in a particular situation there's different measurements, and it occurred to me that you can look at that in different ways. The way you can measure an intensity, an amount, a degree. Use different words like that in some situations to help you understand also. What's the amount of weight? That's like the measurement of weight in a situation. WEIGHT, not WAIT. Height, space, angle. Measurements of angle, measurements of space, measurements of distance. What's stuff like that going on that you can use to think about a situation? And what variable is that? So what, if you got some measurement that's relevant, then, what variable is it? What kind of thing? Length, degree, stuff like that. All right. Now, we'll get into an intro about applying or thinking about how the ecological approach applies to training, and kind of specifically fighting and training BJJ.